Hello, this is Cliff Jordan. I'm with DataGaia, and I'm here to give you a Marketing Attribution 101, as well as a demo of an attribution workflow that we've developed. Let's dive right in. Let's start off with the 101. What is marketing attribution? Well, if you have a company, you have a service and a product that you're selling, you have customers that are buying that service and product, you are more than likely marketing to your customers, and you're probably using many different marketing channels to do that. You may be using email, SMS, telemarketing, you might be using social media, maybe YouTube, perhaps you're using television, maybe you're using radio ads, maybe you're using billboards on the road. All of these are ways to touch your customers and let them see your brand, let them see your service and learn about it. Eventually, your customers, after being touched several times, will say, "Oh, okay, yeah, I'm going to go ahead and purchase that service or purchase that product." And the whole question with marketing attribution is, if you look at in aggregate for a month or a couple months, all the sales that you made, what percentage of those go to each of the channels that are touching all your customers? So let's say you've got several channels, and I've got a list here. Here's some, like if you got email, social media, YouTube, telemarketing, SMS. And let's say these are the channels that you're using, and you've got, 100,000 purchases for $500,000 or euros. And the question is for you, what percentage of that 100,000 purchases and 500,000 euros is my email responsible for? What percentage of all that is my social media channel marketing responsible for? YouTube, etc. This is important for a couple of reasons. One, it allows you to understand how valuable your marketing is for each of these channels, because it tells you how much money, your revenue, you're bringing in because of that channel. Number two, it also allows you to predict the future. You can if this is done accurately enough, and that's the key there, if your attribution is accurate enough, it allows you to actually predict and forecast future sales based on how much money and how much effort you're going to put into each of your different channels. Okay. Now, we can use channels. We can do marketing attribution to channels, but we're not restricted to that at all. Let's say your company has many different campaigns, different types of campaigns, and these different type of campaigns touch your customers. A customer is touched by several campaigns and then makes a decision to buy. You can use the same analytics to figure out across all your different campaigns what percentage of your sales is responsible for each campaign. Also, you could do actual characteristics of campaigns. Let's say that you only have social media ads, and you say, well, we're going to touch people with social media ads with a black background, and then others we're going to do with a white background, and then another one we're going to do with a rainbow background, and then another one we're going to do this and do that. So these are different characteristics of your campaign, and if your customers are making purchases after being touched several times by these different campaign characteristics, you can use the same analytics to actually attribute how much of your sales goes to each of these different characteristics, which helps you in then understanding the value of those different characteristics with respect to each other. You understand which one is working better for you and which one is not. Okay, so marketing attribution, normally you're doing attribution across channels, but you could be across campaigns, or it could be across campaign characteristics. That's why we call each of these channels, campaigns, or whatever, we call an attributa, which is, I think, a Latin term for a single channel or whatever we're going to attribute to. So, like I said before, marketing attribution helps you understand how much each attributor is truly worth. It helps you also to gauge how much investment you should make in each attributed. So let's say that you understand that you sold $1 million or €1 million of a particular product, and your social media ads, we find out through the analytics, is worth about 400,000 euros of the 1 million, 40%. If you're spending $500,000 in marketing on your social media, then you're losing money. It's probably better just to get rid of it altogether. But if you're only spending $300,000 and yet you're getting $400,000 because of that, then you've got a profit. You've got an ROI there. Also, you can use this just to look at the ROI of different channels and compare those and contrast those. And it helps you better determine where to invest your money to get the most results in revenue coming back. Most companies, like I said before, just do an attribution for their channels only, but like I said, you can use it for other things such as campaigns and characteristics. When it comes to marketing attribution, if you go online and you start researching it, you're going to come across a lot of different types of attribution that are really easy to do, but not very accurate. The first one is what we call first touch attribution. If you are hitting your customers, touching your customers with email, SMS, and let's say a social media, if you know that your customer first was interested in your product or service because of the email that you sent to him and he opened that first, then we're going to attribute, using the first touch method, you would attribute all of his sales to email. If another person, if their first touch was the social media ad, then the social media would be 100% of the sales for that person would go to social media. Okay. There's pros and cons with this approach. Pro is super easy. You can do it. You don't need a data scientist to do that type of work. Next, or the con, is that it's not very accurate, and it doesn't really, because it's not accurate, it's not going to help you truly understand the worth of each of your channels. The next one is last touch. And this is where we assign the full amount of revenue for a particular sale to the channel that was the last one right before the purchase. So let's say you hit them up with an SMS first, and then they saw the email, and then they saw the social media ad. Well, social media, if you're using a last touch methodology, social media would get 100% of that person's revenue or attributed to it. Okay. Again, it's very easy. The con, it's not that accurate. Out of all of these four that we're talking, last touch is probably the most accurate, but it's still not that accurate. All right, let's go to the next one, linear touch. Linear touch is where if you've got all your channels and you say, well, hey, I have no idea whether it should be first touch or last touch, or let's just make all of my channels equally the same. And where I've got $1 million of sales, I've got 4 channels, that's 25% across the board for each channel. Okay, this is not accurate at all, super easy, and a lot of companies do that. They don't have data scientists, they don't have a data science team to go in and do all the analytics, so they just say, hey, we'll just make everyone the same. Kind of a democratic approach. The next one is what we call position-based. And this one is typically done where you award most of your attribution to the first because it generated the interest. You award this also to the last, the same amount as your first, because the last is usually what pushed them over the edge. And then all the touches in between are evenly divided across those. So you might have, let's say, 30% for the first, 30% for the last, and that's 60%. So the remaining 40% gets evenly divided for all the channels, all the touches and the channels in between the first and the last touch. Like I said, this is easy. You can do it, not a problem. You don't need a data scientist to do it, but it's not accurate. Okay. Now let's go to some of the more difficult ones. One of the ones that's quite popular is called time decay. And the whole idea of time decay is each of your channels applies towards the total sale for the customer, but the channel worth is dependent on how far the touch was to the purchase. So let's say we had an email that was 14 days before the purchase, and then there's an SMS that was 10 days before the purchase, and then let's say there was a YouTube video 1 day before the purchase. Well, of those three, the YouTube video is going to be weighted a whole lot more because it was the day before. The 10 days before will be weighted much less, and the 14-day touch will be weighted even less. And the values, the weightings that we assign to each of these in a time decay methodology is based on what we call an exponentially decaying curve. Okay, it's a little bit more analytical. You don't necessarily need a data scientist to do it, but again, not that accurate. One of the additional cons, in addition to not being that accurate, is it can promote an overtouch which can scare away patrons. An overtouch situation is where I'm using time decay, if that's the way I'm doing it, could quickly come to the conclusion, well, if I just hit him over and over and over and over and over again in repeated times, eventually he's going to cave and he's going to buy the product. And then the last touch is going to give me the most weight. And then you end up with channels competing each other by hitting him over and over and over. And then in these type of scenarios, depending on your product or service, you could scare away a customer. Okay, you don't want to scare away your customers. You don't want to spend more money than you need to. And so time decay can lead a company to overtouch, to overspend on different channels. All right, the next is a customize. And a customize is basically more often than not a subjective assignment of we believe that email should get 30%. Social media, 15%. It's very subjective. And maybe there might even be some data behind it, but it's not statistically significant or it's not statistically sound, the methodology, and it might be fairly close, but it's not the most accurate way to do it. Some companies do this. It could be suited for a very specific business model or sales model, but again, it is subjective. All right. The most accurate way is through a statistical model. Okay. A statistical model looks at all the sales. It looks at, the order of the sales and all that, and it will use statistics to work out the probabilities of each of the channels contributing to your total sales. It is by far the most accurate method. The con is that it is the most difficult to do. Oftentimes you're going to need a data scientist to actually do the work. Okay, but it is well worth the investment if you're spending a lot of money on different channels and you really want to know how much each channel is bringing you in. It can be very well worth the investment in getting a data scientist to do this. It is difficult, but it can be worth it. For the statistical method of doing marketing attribution, there's two different types or two different algorithms that are commonly used, two basic types of algorithms. One is a regression, and it could either be a linear or a logistic regression, and the other is Markov models. Okay, in the case of a regression, it is based purely, the whole attribution is based purely on correlations between the channels, the amount of activity on the channels, the number of touches, and the final sales. Okay, one of the problems with linear and logistic regression is that it can lead to what we call a negative value assignment for specific channels, which is not always accurate, and it doesn't make sense in a lot of different cases. The other method which is Markov models, which is more accurate and is it's a different approach. Instead of using correlations, it uses probability chains, and specifically it's based on Markov probability chains, and it's represented by what is known as the state graph. Now, I'm going to show you a state graph, an example, in just a minute, but so you'll understand what that is. Overall, Markov models are a little bit more difficult to understand than linear or logistic regressions, but they are much more accurate, and they do take longer to compute generally because they're done through simulations, and I'll explain that as well. The other thing is that Markov models do account for non-purchases due to what we call infinite path circles. What can happen, and you'll see in the state graph, is you can kind of end up in an infinite path circle, and Markov model analysis takes care of that. Like I said before, it is more accurate than the regression methods, and it is right now the state of the art for doing marketing attributions. Let me show you what a state graph looks like. So this is for a sample set of data that is, imagine we got a video game company that is selling video games, and they're selling across 5 different channels. One is an email channel, which is right here. This is your email channel. They're doing a social media channel, and they're also doing in-game promotions or in-game advertisements. So what an in-game is when you are playing a game on the console, be it PlayStation or Xbox, you get an advertisement sent to you either right before the game starts or maybe while you're waiting, as in part of the game, but you get an advertisement. And then we have YouTube videos, and YouTube is commonly used it's commonly used in the gaming industry for reviews of games. So a video game company will pay a reviewer to review the game, and provided it's a good review, then they advertise the YouTube video. Another channel that is common in the video game industry is called Twitch. Twitch think of it as like YouTube for games, where most of the videos in Twitch are people or avid game players playing games. So what they do is they'll take someone who's really good at playing a game, and they'll do a Twitch video of him playing the game. And all the hardcore gamers like to watch the Twitch videos because through the Twitch videos they get an idea of how the game actually plays. They also get an idea of what are the secrets, what are the secret places, what are the secret things that you can find, etc. A lot of that is done through Twitch videos. You can pass that on. So anyways, Twitch is a channel that some companies use to market their games. So in this example, for a particular set period of time, and we'll say that period of time is 1 month, this would show the state graph for all the different possible paths to a purchase. Let's say everything always has a start. And let's say for a particular person, the first thing he got from the video game company was a social media ad. So he would go from start to social media across this path right here. And then let's say when he got the social media ad, in the ad itself, there was a link to a YouTube video. So he says, okay, fine, I'll go to the YouTube video, and now he's here. And let's say after he watches the YouTube video, he's fine. But let's say the next day, the video game company then sends him an email. He gets the email, he opens it up, goes, oh, that's cool. I remember that video. And then he clicks on the Twitch video, or the Twitch link, or the link to see the Twitch video. So now he goes from there to here, goes down this path here. So after watching the Twitch video, he's sold. He says, oh, fine, I like this. Let's go ahead and purchase it. He goes and he does a purchase of the game. Okay. Or let's say that he didn't have the money that month, so he's fine. He just retires it. And so at the end of the month comes and there's he goes no further. And so it's essentially it goes to a non-purchase. So in this particular example, this person would go from start to social media, to YouTube, to email, to Twitch, and then to purchase or not purchase. Okay. So that is what we call the path. Now, on this next slide, I'm showing what is known as the probabilities associated in each transition from one node to the next. So going from start to social media, being that we've got we got email, we got YouTube, Twitch, and IG, all as possible places to start. 18.8% of the time, social media ends up being the first thing that they see right off the gate. Okay, and being that he can click on a link to go to YouTube, there's the probability of making that click, from going from social media to the YouTube video, is 44.66%. Okay, so it goes down this path. Okay, then the probability that the next thing that he's going to get and open would be an email is 15.5 or 15.49%. So that would put him here. And then the probability of going from email to Twitch is click on that Twitch link, is a 51.6% probability. So that would bring him here. And then the probability of going from Twitch to purchase is 26.59%, or to not purchase is 4.73%. So this is our state graph, but now with all the probabilities, and those probabilities come from what we call the transition matrix. Okay, with this data, we can now calculate the total probability of any single path. So let's say we got the person, they went from social media to YouTube, email, Twitch, and purchase. The total probability of a purchase following that specific path is, you multiply all of the probabilities. So it'd be 18.8% times 44.66% times 15.49%, 51.6%, and 26.59%. You multiply them all together, that gives you the total probability of that path leading to a purchase. Okay, you can hopefully see the value of this. If you can calculate the probabilities for a purchase for any particular path, then through this analysis, we can then use this to figure out what are the most probable paths that lead to a purchase. This would help your company design a campaign that would help push your potential buyers through these different nodes to get them excited, to do all the things that are needed by each of these touches to get them excited about making the purchase. So with this data, which is one of the things that we would give you, is the state graph plus all the transition probabilities to allow you to design campaigns to maximize the purchases. Okay? All right. More on Markov models really quick. We've talked about this already. The purchase path probability, what we just talked about, you can calculate that probability for every path. The last thing I want to talk about is called the removal effect. And what the removal effect is, this is how we can actually determine for email or for every channel how many of the purchases and how many of the dollars or the euros was that particular channel responsible for. This is how you do it. Imagine we have 18,900 and some odd total conversions in the month for all 5 of those channels: email, social media, in-game, Twitch, and YouTube. Now what you do is you take away one of them, we'll take away email, and then you do simulations to see where people fall out and see how many conversions you have after that. And you do simulations based on the probabilities to see where they go, and then see how many conversions you have when you take out the email channel. That delta, the total number of conversions we had before, minus the total number of conversions we had without the email, that is the number of conversions that email is officially responsible for. Those are conversions you could not have happened unless you had email there. Okay, so you end up doing this removal effect, calculating this removal effect for all the channels, and this is how you can calculate exactly what percentage for each of the channels, what percentage of the total number of conversions and or dollars and or euros they are responsible for. So this is a very important part. This is just a particular thought. I want to discuss infinite loops. Going back here, what I wanted to say is that it's very possible when you have a state graph, especially with multi-channels like this, it's not only probable, it's like most of the time you have probabilities of infinite loops where you could go into like a social media, get a YouTube, and then he does nothing, and then he gets another social media ad, clicks on it, and then goes to a Twitch, nothing, gets another social media, goes back to YouTube, nothing, social media. So the thing is, they never buy. Okay, you have an infinite number of these infinite paths. Okay, I mean, you could just keep circling around and around and around, and that would be considered an infinite number of times, and that would be considered its own path. Or you could go an infinite number of times here, or half an infinite number, and then half an infinite number of times here. You get the idea. You can have an infinite number of these paths. So the thought is real simply, if you could determine all the possible paths, then you could determine all possible probabilities towards purchase and accurately define the value of each channel, which is true. But like I said, in most cases, some paths can be infinite loops, and thus determining all possible paths cannot be determined. Because of this problem, the only way that you can accurately do your determinations is through simulations. Okay? So, and that's exactly what we do. When we take your data and when we're figuring this out, when we do the removal effect, we do simulations. And the number of simulations, the greater the number of simulations, the more accurate of the output we're going to get from the removal effect calculations. Okay, so if we do 100,000, it'll give us a certain number. If we do 1 million, it's going to be more accurate. And hopefully this makes sense to you. The last thing I wanted to show you is what our workflow looks like. This has been fully developed, been fully tested. This is like the data that we've already prepped and putting into. These are a couple of macros. Oh, by the way, this is what was known as an Alteryx workflow. Alteryx is like is an environment used for analytics. It's also used for manipulating data, and it's a very popular platform that's being used now. But anyways, this takes the input data, which has been prepared and set up with all the data in the right format, and it inputs it into one of these two macros. This one's a macro that does all the calculations. It does the removal effect. It does the transition matrix, all of that inside this macro. This one has actually been developed using R code. So Alteryx has an interface to R, and so inside of that macro is all R. This particular macro is it's all written in Python. So if you have any specific needs, requirements, it would be regulatory, governmental, or whatever, to say, hey, no, it has to be Python, we got you covered. If it can be R code, we got you covered. Okay. Let me show you an actual demo. So this is one of those macros. Here, for example, this is what I showed you before. This is our macro that's in R. This is our macro in Python. And here is the macro in R. Okay, so this part right here just helps us calculate all the configuration of the macro and how we're going to do the modeling. This is where all the secret sauce happens. This is where all the R code is. And this is all the R code right here. On the output here, we've got these. We then get a bunch of reports, get all the data on the output, and then we manipulate it to make it nice and easy to read. And so, for example, on the output of this particular demo, that video game demo, we see we've got the 5 channels here: email, IG, SM, TW, or Twitch, and YouTube. And then we've got one row here which shows all channels. What this number is the total number of touches, the total number of conversions, for all of the channels when they were all together. Now remember, we talked about the different methods of doing it. We actually calculate those methods inside the macro as well. So we do the Markov modeling, but we also do a first touch and a last touch just to compare. So this is, if you were to do a first touch with this sample data, this is how it would work out. For out of the 18,987 conversions, 2,210 were attributable to email. 6,638 was IG, SM was 3,297, and so on. This is how they line up for last touch methodology. Then linear touch is where we give them the same amount of weight across the board. And this is kind of how it all works out for that. And then this is the Markov model. Okay, like I said, the Markov model is statistically much more accurate than the first touch, last touch, or the linear touch, and better than the time decay, which is I don't include here, but it's better than that. This gives you the percent. So out of that 18,987 conversions, 2460 was due to email. IG in-game was 3949, and then I give you the percentages here. Now this does break out all the conversions according to the different channels, but over here to the right, it breaks out the total value of those conversions according to the channels. So those 18,987 conversions led to $1.4 million in video game sales. This is how it breaks out across all of those channels. So 131,780 was for email, 297 was for IG in-game, and then social media was 174,000. You can see right here, this will tell you exactly how much value in money are you getting from that channel, which is very important if you're trying to tune your channels. If you're getting $137,000, 780 cents of revenue from the email channel, you don't want to spend more than that. You don't want to be spending $200,000. You want to be spending much less than that. Okay. If you know how much you're spending per channel, then you can calculate an ROI for each channel as well. Okay. So there you go. Oh, by the way, that's the linear touch. This is the Markov model, and this is the Markov model percent here for the revenue. All right. If you have any questions, that's the end. We're at the end of the demo. We're at the end of the class. If you have any questions about either marketing attribution and the theory behind it, first touch, last touch, linear, or time decay, please get with us. We'll explain that because we know how to do those just as well. If you want to know, better understand, or if you have any questions about how Markov models work, please get with us and we can explain how they work in more detail if you'd like. But if you want to do some testing, please get with us and we can do some testing as well. Thank you very much, and hopefully we'll talk to you soon.